So I've mentioned that we actually do infinite sums all the time. Every single decimal expansion for a real number consists of digits, right? There's some integer part, and there is a decimal point, and then what comes to the right of the decimal point could be infinitely many digits. And what these digits are represent, the tenths place, the 100th place, the 1000th place, and so on. But what are they, from a technical perspective? Those are numerators on these fractions. 1 divided by 10, 4 divided by 100, 1 divided by 1,000. And there's something to be said, but how do we know that this works? Maybe in the past we were told that it just works. We get used to it. But I would like to be able to add up infinitely many things, even when they are not decimal expansions for some real number. I'd like to have a tool that does a little bit better than just that alone. So keep in mind, we're using sigma notation to represent these series. So we have some list of numbers, some sequence, starting at A1 and then A2 and then A3 and A4 and so on. Or, maybe your sequence starts at A1000 and then A1001 and A1002 and so on. The labels don't end up mattering too much. But the problem here that we're trying to resolve is that we do have infinitely many things on this list which we are trying to add up. And we'd like to figure out whether or not there is a way we can make sense of that operation. So if I was going to add up 1 plus 1 plus 1 plus 1 plus 1, well, I would think naively that doesn't really equal anything, because it's certainly going to be bigger than 2. It's certainly going to be bigger than 3. It's certainly going to be bigger than 4, and so on. So that seems like it would diverge. Now, some series will have a nice formula, and we will be learning those. But other series just don't. Not everything in the mathematical universe was created to be easy for us. So, in general, even if I don't have a formula for my terms of the series, the thing I am interested in is what happens if we start at the first number on the list and add up, say, the next number, the number after that, the number after that, and so on, and we stop. Well, that would just be an ordinary addition. It might be a while to calculate that, but we wouldn't have this sort of philosophical problem of adding up infinitely many things. And if I just took the first number by itself, sure, fine. If I took the second number and I added the first two together, okay, that would be some summation. If I took the first 3 numbers and added them all up, that'd give me some summation. So we would call these the partial sums. I haven't added up infinitely many things just yet, but I can always stop at some finite amount, some finite list of these numbers, add them all up and see what I get. So here's even a table where we've done just that. Now, this series does have a formula. but we want to be able to use this tool even in cases where the series is not so nice that we can do that every single time.